In this video, I'm going to show you how to build RAG Vectorstores with LangChain. This is really powerful because it sets the foundation for you to build chatbots that use custom data sources. So if you want to build a chatbot that uses a custom knowledge base, or can use custom documents, or just can do a search query and then use that, use results from a search query inside of the chat response, this is how you do that. This is going to be the first of two labs on this topic. The first one is an intro. This one is an intro. It just covers how to use LangChain to build a vector store, how to populate the vector store, and how to query it. And then in the next video, I'll show you how to build something more advanced. If you want to follow along on SkillMix, you can. Just go to skillmix.io and create an account, and then you'll be able to access the dashboard. You can also follow along anywhere that you can run Python. Just make sure you have Python 3.12 installed. So Python 3.12. So you come here and go to module 4, and if you don't know what RAG is, you can read this lesson and you'll learn about the core parts of RAG, such as why it's needed. The main issue is that the models, that are built, GPT-4, GPT-5, they're static. They have a fixed set of knowledge in it. They don't have knowledge, of new updated materials that come online. They don't have access to your internal data. They can hallucinate. If they don't have the right data, they might make it up. And of course, you can't get citations. So if you do have, let's say, your own custom knowledge base, it's not going to tell somebody where it's at in the knowledge base. So go ahead and read through this. It talks about the problems. It goes over embeddings, which is important. It talks about vector stores. It talks about retrieval chains and a few other things. So check that out, and then you can come back to the actual lab. So we're just going to build a vector store here, and once you have this open, click Start Lab. And if you're following along on your own machine, then you could just open up this lesson tab, and then you'll have access to all the information. Okay, we're going to wait for the lab to start running. It usually takes about 1 minute because it's starting up a server on an Amazon account. Alrighty, so now our lab environment is ready. You may see these connection errors because the server is still coming online technically, and it should take a few more attempts. If you need to, you can always just put your focus in the terminal and press enter, and it should work. So let's bounce over to the lesson, and there's a few things we have to do to set things up. So I'm going to go ahead and create a virtual environment, and then we'll activate it once it's all set. Okay, and then we can check our version, go Python, so 3.12. Alrighty, so we do need to install a bunch of requirements, and you can just copy and paste this. And let these complete. And if you don't have an OpenAI account yet, you will need one. So go ahead and create an account at OpenAI, and then you can get your API key. I've provided links to this in other lessons. It's not hard to find. Just do a quick Google search if you don't have it. Okay, so we need to export this. So I'm just going to grab this text, and then I'm going to grab my key. And if you're wondering, yes, I do delete these keys after each session, so you can't use that key. Let's go ahead and just follow the step through here. So I'm going to create a new file called buildvectorstore.py, and then you'll see here on the left, you can open it, and let's copy everything over. It's not a very big file. Okay. So there is a breakdown here if you want to read through it. I'll also read through it right now. So we're going to import several packages. So the first one is the OS because we need to get the API key. We also need to create the OpenAI embeddings, and this part is important because when you first build your vector store, and then when you want to retrieve from it, you have to use the same embeddings, right? And so OpenAI makes some good ones. There are other providers out there who also make embeddings, so you can learn more about that if you want to. We're also going to use the Facebook vector store called FAS. So if you were to just do a Google search, you'll see that Facebook created this vector store. It runs in memory, so it's good for building things out during lab environments because we don't need an external service or our own database running to test things out. Okay, so we're also going to use a text splitter called a recursive character text splitter. This is because we want to logically break up our documents into chunks. We typically don't store the whole document in one vector store. We break it into smaller chunks, and so that when we're doing a similarity search, we get those smaller chunks, and then we can reconstitute a response based on that. And then we import this documents handler. It's a little helper that helps LangChain work with documents in a more logical way, like within our in this context, it'll be within the chunks that we break down from our main documents. Okay, so there's that. And again, if you're new to SkillMix, you can always pop over to this tab and then ask questions. There's an AI right there if something wasn't clear that I said or you want more details on something. So go ahead, or I'm sorry, so we gone over the imports. Now we get our API key from the environment. This statement right here, export this key, that's what set this environment variable. And then we create some sample documents. Here we're just manufacturing some text, right? There's an HR policy FAQ, there's a product documentation. There's only 2 documents, so to speak, here. Obviously in production or in other environments, you would want the data to come from somewhere else. Maybe it's PDFs, maybe it's a database. Whatever text-based documents you have, you can use those. But for this, we're just using a simple array here. So we first create our splitter, and we're setting chunk size to 500 and overlap. So what this does is it looks through the text, creates a chunk of 500 characters. So if you have 1,000 characters, you'll have 2 chunks. But it also does some overlap. It will overlap each set by 50 characters. And that helps with understanding, when you're doing a similarity search and retrieval, you have a little bit of overlap to see where things were close together in an actual document. So then we create a docs array, and then we enumerate over our sample docs. And what we're doing is we're appending each of the chunks to the doc with some metadata. So we're saying our metadata, the source is HR, FAQ, and product docs. This is actually where if it was a PDF, you'd be able to set metadata like page number and URL or whatever it is. You can be quite flexible on the metadata side. So then we're just going to print it, and you'll see when we run this code, you'll see the output of how many chunks there are. Then we create our OpenAI embeddings, and we're setting the model to text embedding 3 small. This is specific to OpenAI, and this is an actual embedding model on their side. You can use different ones, and you can read about them here. So just make sure you're using the right name for the current embedding model. Okay, so that was this line. We create our embeddings model. Then we create the actual vector store, and we're populating our vector store from documents, and we pass in the documents here. So this is our documents array, and then we pass in the embeddings model, and that's what the FAS, the vector store, needs in order to build its vector store. So then we have a couple print statements here. So this is all that's needed to really create, to chunk your documents and to create an embedding store. It's not that much work. In production, you might have to do a little bit more because maybe you're reading through a bunch of documents, like a bunch of PDFs, and you have to handle a larger task, right? So it can get more complicated, but at its very basics, it's pretty straightforward. And then we have a test search here. So we're going to say, what are the remote work benefits? And we'd expect that it's able to come back with obviously information here about the remote work policy. So let's see what happens. I'm going to expand this a little bit, and then we will run the Python file. So right away we see it's splitting into two chunks, and we have two vectors. Each vector has 1,536 dimensions. That's determined by the model, so that comes from our model. And the first result is the HR FAQ, and so it's saying, basically, it's answering the question that we had. And then it has the second result, and this partially could be due to the overlap that we had in there, and also it's just that we've asked it to return 2 responses, and there's only 2 in the database. So it's probably just the fact that we only have 2 and we get 2 back. Those are the top 2. So that's that. This is the bare bones kind of how to do how to create a vector store and retrieve from it. Now what you noticed is that we didn't actually pass this data to OpenAI and ask for a response back from an LLM. That will happen in the next lab. So if you want to see that, watch the next lesson, and then you will learn how to pull from a PDF, and you will learn how to pass that final result to ChatGPT or to OpenAI and get a response.